Today you're going to learn about arithmetic sequences. At the top of your paper, please write it down. You learned this concept freshman year. We are going to revisit it and then increase the strength slightly with fractions and applying it to real-world problems. So what is an arithmetic sequence? I'm going to give you two examples. Both of these are examples of arithmetic sequences. Arithmetic sequences would be a list of numbers, and to get from one number to the next, you have a common difference. So in this case, I'm adding 2 every time. In this case, to go from 5 to -1 to -7 to -13, you are subtracting 6 every time. Has to be the exact same number. It cannot do something like this. I'm going to go up by 2 and then 4 and then 6 and 8. Has to be the same number every time. Again, +2 and -6. Now, how do you actually get this? So we have something called a common difference. And we use the variable d to represent the common difference. And really easy problems like the first example, you may achieve the common difference by simply looking and going, okay, I can recognize that I'm going to go up by 2, so d equals 2. If you don't recognize it, this will work every single time. Take the second term and subtract it by the first term. So like for this one, maybe you don't recognize that it's -6. Take the second term and subtract it by the first term. -1 subtract 5 is -6. The negative sign means you're going downwards 6 units from one term to the next. There are two formulas you learned about freshman year. One is called the explicit formula and one is called the recursive formula. Both formulas allow us to identify the value of any term within the sequence. So if that sounds confusing, I'll give you an example. The value of the first term is 3 in the sequence. The value of the second term is 5. The value of the third term is 7. So I could say, using either one of these formulas, I could go, what is the value of the 15th term? And so I'd go over 15, and I'd figure out what is that value using either one of the formulas. Here's the general formula for explicit. Here's the general formula for recursive. A sub 1 represents the first number in the sequence. D is the common difference. I prefer to use explicit. I think it's easier to apply. You do have to know how to write a formula for both given an arithmetic sequence. So let's start with something easy. The first question is this an arithmetic sequence? So is there a common difference that's applied as you move to the right? So let's check it out. I'm going to go common difference would be 1 subtract -3. 2 negatives make a positive, and the common difference would be 4. So if I add 4, I get 1. Good. If I add 4 to 1, 5. If I add 4 to 5, I get 9. This works. This is an example of an arithmetic sequence. When your answer is yes, this is arithmetic, then I can write an equation both explicit and recursive. If the answer is no, I just stop. Nope, it's not arithmetic sequence, and you don't have to do any more. Okay, so explicit. I know the first number here in this sequence is a -3. Once I have these two values, the common difference and the first value, I can go ahead and write an equation for both. We're going to start with explicit. A sub n equals the first number plus the common difference times the quantity n subtract 1. Distribute the 4 and combine like terms. How can I use this? Well, if somebody just said, what's the fifth number in the sequence, I would just do basic mental math. I would add 4 and say 13. But what if somebody said the 21st term? So if somebody said the 21st term, a sub 21 represents what is the value of the 21st term. So I'm going to plug in 21 for n, and you can either use mental math or you can grab a calculator. I know 4 times 21 is 84, and if I take 7 away from 84, I end up with an answer of, can you check my math? I believe it is 77. Please take 4 times 21 on your calculator and subtract 7 to verify that the answer is 77. Yes, no? Okay. What does this mean again? If I find the 21st term, so if I went all the way out to 21, the value of that 21st term in the sequence would be 77. Recursive, the first term is -3, and the common difference is 4. There is your recursive formula. It can also be used to find the value of any term within the sequence. Okay, please write down the next list of numbers. The first question is this list of numbers an example of an arithmetic sequence? If the answer is yes, we write down both formulas, explicit and recursive. If the answer is no, we just write down the response no. So let's figure out the common difference. I take the second term and I subtract the first term. The common difference is -5. Grab the calculator, type in 3. Subtract 5 from 3. Okay, great, good. I got to keep going. Subtract 5 from -2. Great. Once you've done something twice on your calculator, it remembers the pattern, and now you just can go down to the very bottom, find the enter sign, and you can just press it. Okay, here's the problem. The next term, when you subtract 5, should be -12, but I have -11. The answer is no, not an arithmetic sequence. You do not have to write down that list of numbers, but what I'd like you to do in the next 30 seconds is I want you to find out, is that list of numbers an example of an arithmetic sequence? Use your calculator, write down whatever you need to. 30 seconds begins now. Is it an example? Yes. It is. Please go ahead and write an explicit or recursive formula. can you give me feedback, honest feedback, on a scale from 1 to 5 if time is not a factor? What is your level of understanding with this concept? 1 through 5, 5 being the highest. Okay, totally fine to be a 1 or 2, totally fine. Can you raise your hand if you remember doing this freshman year, even if it hasn't come back to you fully yet? So at least half of us, okay? So now we're going to take, and we want to figure out, in this particular arithmetic sequence, I want to know what is the 20th term. So here's how you write it. This means what is, together, what is the value of the 20th term. So use either one of these. This is going to be your user-friendly one because here you'd have to know the previous number to get the answer. If you're substituting 20 in, many of you will do mental math. -3 times 20 is -60. Plus 5 is -55. The 20th term in this arithmetic sequence has a value of -55. All right, it's time to enter into more of Algebra 3-4 land. Here we go. If you understand the concepts, the calculator does the hard work, and there's no difference from the last few problems you've done to this one. I'm going to tell you that this particular list of numbers is an arithmetic sequence. You don't need to test it. I'm telling you it is. But I do want you to write a formula, both explicit and recursive, for this. So here's the first thing. You ready? A sub 1 equals 1/4. The common difference is write down the second term, subtract the first. Don't bother with finding, unless you can do it real quick with finding a common denominator. We're going to use our calculator to do the hard stuff. Type in 7/12 in parentheses, then subtract in parentheses 1/4. This is a subtraction sign, not a negative sign. You're going to get a decimal. On the left-hand side, you're going to find the button that says math. Press it once. Fraction is highlighted, and press enter twice. The common difference is 1/3. By a raise of hands, who was able to get 1/3 with me as I went through the calculator operations? Okay, so here we go. We're going to write with our explicit formula. A of n equals the first number plus a common difference of n minus 1. I'm going to distribute the 1/3 to both. I end up with 1/4 plus 1/3 n, subtract 1/3. So there's 3 terms here. The ones that are like terms that I can combine is 1/4 and -1/3. Grab the calculator again, let it do the hard work. In parentheses 1/4 plus, in parentheses, the negative sign now is below the 3, -1/3. Hit enter and hit math fraction, enter, enter. -1/12 is our answer, -1/12. So this is A sub n. A of n is equal to 1/3 n minus 1/12. There's our explicit formula. Recursive is A sub 1 is 1/4. A sub n is A sub n minus 1 plus a common difference of 1/3. Okay, when I write this down, what does this mean? This means I want to know what is the value of the 9th term in this arithmetic sequence. So we're going to substitute a 9 in here, and we're going to get an answer. We want to know what is the value of the 9th term. Grabbing your calculator again, please. Start by putting 1/3 in parentheses. A 9 in parentheses right behind it. Then we're going to subtract a 1/12. And we're going to get this ugly decimal. Raise of hands, who else has this decimal answer? Hit the button that says math. Fraction is highlighted and press enter twice. 35/12. 35/12. What does this mean? That means that. Here we go. This means that the 9th term in this sequence up here would be 35 over 12. Okay, so now we have to learn to apply this. Let me think of a word problem here. Okay, so we have the theater club. By the way, when you guys see an auditorium, do you recognize that they often look like this? If this is the stage area, it's often very few front row seats, and then as it goes backwards, there's more and more seats. Okay, so our theater club at Trevor Brown took 35 students to ASU, 35 students. And they are going to watch a show being presented at ASU. And what we know about this auditorium is this first row contains 25 seats. And every row after the first row has one additional seat. Every row after the first row has one additional seat. Those 35 students want to be all in the same row. They want to, from the front to the end of one row, we want it to be entirely filled with only Trevor Brown theater students. There's 35 students going. From the front, which row would they have to request so that all 35 students could fit into just that row? You have 1 minute, begin. Okay, ready? Common sense. Who has an answer just using common sense? Okay. Ruben, can I call on you to work through this? I'm hoping you don't have an answer. So I'm looking for somebody who does not have an answer. But you can get the answer and I'll help you in like 10 seconds. Ruben, am I correct? You don't have an answer? Can I help you to give you a few hints and you can share it with us? Okay. What's the first row? Okay, everybody needs to listen to Ruben. What's the next row, Ruben? Who can tell Ruben what's the next row? How do we know it's 26? Okay, so 26. Ruben, what's the next row? What's the next row, Ruben? You guys understand the pattern here, right? And how many students went on the trip?
35.
And we only want those 35 to be in one row. So it's 29, 30, 31, 32, 33, 34, 35. Row 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Who understands 11 rows? Raise of hands. Now, is there a way that we could have achieved that answer in using what we have just learned today? And there is. Here we go. What is the first number in this list?
24.
What is it consistently going up by?
1.
Okay. So keep this in mind. So I'm going to use explicit. First plus 1 times n minus 1. I'm going to distribute the 1. And I'm going to combine like terms to end up with this amount. Now, how is that going to help us? This is your row, and this is your quantity of how many students can fit in that row, or people can fit in that row. I want to know which row can I hold 35. So 35 equals 1n plus 24. What'd you say? So I'm going to subtract 24 from the opposite side. I get 11 equals 1n. This means the 11th row can hold all the students. Where did you get minus 25, Vivian?
No, minus 24. Because usually you distribute.
Yeah. So you end up with a negative 1, but negative 1 plus 25 would be a positive 24. Different sign, subtract, keep sign larger. Does that make sense? Okay.
I think that's the right answer.
Okay.